Hi, my name is Arturo Saldivar, and I chose this topic because I want the students to feel and experience the same success they do have when they work in groups and they're doing labs, which is very different than to solving problems. So I chose this topic because of that reason. Okay, so as you can see on slide 1, the title of my research study is The Effect of Group Work for Solving Physics Problems on Student Behavior. Okay. Now you will see that this was chosen as there were several problems. The first problem all students experience in physics is that they have a hard time figuring out how to solve problems. Next problem is that the teacher usually cannot get around to help every single student in one class period. So, the students usually get frustrated by this. When the teacher cannot get around to help them, they get frustrated. If they get frustrated, they show this in off-task behavior. And usually that off-task behavior is not just secluded to them. They show it to the rest of the class, disrupting everybody, and then everybody's scores or academic achievement decreases because of this. Now on slide 3, you see that these questions were developed because of the problem. The main question that this study was able to answer was, what effect will group work while solving physics problems have on student behavior? So we want to answer with this study if putting students together in groups to solve problems can help them and also reduce behavior. So that takes us to the first sub-question, which is what effect will group work to solve physics problems have on the ability of the students to understand and solve physics problems? So we can also know if putting them in groups can help them solve the problems better. And the next sub-question is, what effect will pairing students with the same learning style have on their ability to understand and solve physics problems? So now we want to know if having students with the same learning style together, it's better for them, or it's better to have different learning styles. Okay, now for the theoretical framework. This research study was based on the foundation established by social learning theory. Social learning theory established that an individual's behavior is motivated by his or her unconscious needs, drives, and impulses. Social learning happens when a change in understanding has taken place in the individual involved. This change that took place goes beyond the individual and is found within a social unit or a community, and that it occurs through social interactions and the process between individuals within a social network. Now, social learning theory has been used to try and help individuals in need in order to change human behavior. The behavior the study is trying to change is the one that prevents students and his or her peers from learning by having them cooperate together in groups to achieve a common goal. Next slide. Now we're going to talk about student behavior. Now, students that show behavioral difficulties in a class, they significantly reduce their ability to be successful both academically and socially. So this doesn't affect the students only in school, it also affects them outside of school. Now, misbehavior in school often results in the loss of instructional time because the teacher has to constantly remind the student to be quiet or get on task. Now, attrition and also teacher stress. Teachers get stressed because the students don't listen or don't want to do what they're supposed to do. So, small group instruction provides the opportunity for a more positive teacher-student relationship. Now, this has been observed to help reduce student misbehavior in the classroom. So, a positive teacher-student relationship also helps with the student behavior. Now, also interventions that do not make the students feel they are being punished, like when they are put into a small group to give them preferential seating or having work together in small groups. It helps them identify what triggers their behavior, and when they do that, they're able to control themselves and effectively reduce that disruptive behavior. So, by putting them in small groups, the students can know what triggers their behavior. Once they find that, then they can minimize that behavior and get the trigger out of the way. Now, cooperative learning. Cooperative learning. This is students naturally seek the help of other students when they have trouble understanding something, and often students tend to help each other learn. Cooperative learning is not only beneficial for the academic achievement of the student, but also increases the self-esteem of the students. Attendance, time spent on task, social interactions of students, and also of the school and the subject being taught. So when students are given adequate time to help each other, it would result in a higher academic achievement than if they work only by themselves. So it has been proven that when students cooperate with each other, it's better for them than if they work alone. So students work together, right? We usually put them into what is group work. So the teacher plays a very important role in the construction of groups and how they will ultimately be successful or not. This in turn affects the students' future attitude towards group work, because it is not as simple as just to place the students in groups and then expect them to spontaneously work on the task or the assignment at hand without any guidance, especially from the teacher. Now, in order for group work to be successful, it has to follow a clear process. So the first step has to be the group design and the development of the group. Now, the second step is the group operation. And the third and last step is the group output. Is the output of the group beneficial or not? And then also the disbanding of the group. So when you separate the group, do students still work together? They don't. So we have to be careful on that. Now, it is more beneficial for students to be in a permanent group rather than in a temporary group. Now, as teachers always think that, no, I don't want the same students working always the same, because then they'll get comfortable with each other and then they will stop working. Well, research says that it's better for them to be in the same groups. So this is because permanent groups, right, it accounts for individual accountability of the student, and this increases, right, and decreases the free riding, and encourage members to participate and contribute, because group members understand that they are responsible for the work they are assigned. Next slide. So, what were the methods used in this study? Well, this was a mixed method design. Both quantitative and qualitative data were collected. The quantitative data was gathered through giving a pre-test at the beginning of the lesson and then giving a post-test after the students were finishing working in groups. Then the qualitative data was collected through observations of the students' behavior before, during, and after the lesson. And then after the lessons were done, the students were asked 2 questions. So, who are the students that participated in this study? There were 16 participants. 11 of them were males, 5 were females. They mainly comprised 11 graders. All of these students had previously failed physics class, and all of them had a minimum of at least 3 disciplinary reports during the 2018-2019 school year. That's why this made them very good candidates for this research study. Now, the study followed the sequential order. First, the students were given the questions in the learning style questionnaire, and then they determined their learning preference. Using the results from here, the students were placed into groups of 4 students consisting of 2 groups with accommodative learning style, 1 group of divergent learning style, and the last group was a mix between 2 convergent students and 2 assimilative students. After this, at the beginning of the lesson, the students were given a pretest to be used as a baseline of their understanding and ability to solve physics problems. And also this time, the student behavior was observed and recorded. Once the lecture ended, the students worked on physics problems in their respective groups and their behavior was again observed and recorded. At the end of each lesson, the student took a post-test to determine if there was an increase in their level of knowledge, and again behavior was recorded. All these steps were followed for each one of the 3 lessons. Motion in 1 dimension was the first lesson, motion in 2 dimensions was the next lesson, and the last lesson was Newton's laws of motion. Now all this was making sure the students were always back in the same groups. At the end of the 3 lessons, the students answered 2 questions related to working in groups. Okay, so quantitative data. First, the students were given the learning style inventory questionnaire. At the beginning of the course, they were answered the 10 questions that come in the learning style questionnaire. Then they added the scores for each of the 4 learning characteristics. As you can see in the image, one of the columns has questions for the specific learning characteristics, and the scores placed in the learning style inventory map so they could determine their learning style preference. You can refer to Appendix A in my thesis for the learning style inventory map. Then, a pretest consisting of 10 items was administered to the students before each one of the 3 lessons. And then a post-test was administered, also consisting of 10 items, at the end of the lesson after the student had been working in groups to solve problems. Qualitative data. Now, qualitative data was collected in an instrument like the one in the image in the slide by observing the behavior displayed by the students. If the student displayed an off-task behavior, it was recorded as observed. And if the student did not display any off-task behavior, it was recorded as none. The observations were made at the beginning of the lesson, during the pretest. The second behavior observation happened when the students were working in groups, and the third and last observation happened after the groups were disbanded at the ending part of the lesson and during the post-test. This was done for each one of the 3 lessons. Now, at the end of the 3 lessons, the students were asked 2 questions related to their experience working in groups. The first question was, did you like working in a group to solve physics problems? And the second question was, do you feel you learned better working in a group? These questions were just a simple yes or no answer. Now, the data collected to answer the main question of the study, which was, what effect will group work while solving physics problems have on student behavior, is shown here. If we look at the graph, we can observe a decrease in off-task behavior from the students. At the beginning of the lesson, we can observe that the off-task behavior of the students was the highest, and we can also observe that it was decreased considerably during group work. In fact, the off-task behavior was observed to be reduced 58.57% during group work. This result paired with the students' responses to the survey questions, where 75% of the students liked group work and 100% of the students felt it helped them learn better, is extremely significant and provides a strong evidence that group work helps in the reduction of student behavior problems. Next slide. The first sub-question in the research study, which is what effect will group work to solve physics problems have on the ability of the students to understand and solve physics problems, was answered by the pretest and post-test data. Now, the graph in the slide was made using the average score that the students obtain in the pretest and the post-test. The orange shows the pretest, the red shows the post-test, and this is the average scores. Now, the average difference in score was found to be 14.38% for motion in 1 dimension, 7.5% for motion in 2 dimensions, which is not statistically significant, but still it's an increase, and 20.62% for Newton's laws of motion. The overall score for the 3 pretest was found to be 40.92%. Now, this result is significant because it is well below the 55% score needed to pass what would have been the physics STAR test, and it is also the score used for passing the benchmark examination in the district, which tests these 3 subjects. The post-test data was found to be 57.08%, showing an increase in average score that would have made the students pass the STAR test as well as the district benchmark. This result supports a positive effect from working in groups to solve physics problems on the academic achievement of the students. Next slide. The second sub-question in the research study that was attempted to be answered was, what effect will pairing students with the same learning style have on their ability to understand and solve physics problems? Now, the learning style preference of the students were found and are displayed in the pie graph in the slide. The graph shows that there were 8 accommodative learning styles, 4 divergent, 2 assimilative, and 2 convergent learning styles. You can refer to Appendix A in my thesis for the learning styles and what encompasses each one of them. Using these results, the students were placed into groups of 4 students, 2 groups with accommodative learning styles, 1 group with divergent learning style, and the last group was a mix with the 2 convergent and the 2 assimilative learning style students. Now, unfortunately, there was no statistical significant correlation found from the scores of the students in the same learning style group to the scores of the group with different learning styles. Now, this might be due because the